the gait of the patient, how the patient is approaching to us, and our evaluation starts from the gait by which the patient is approaching to us. Then only we can detect some clue points from the gait so that we'll go forward for further evaluation of the patient. So this is an interesting topic today for all young physiatrists and students about gait analysis. Rather normal gait analysis, we must know about the normal gait and then only we can detect any abnormality in the gait. So for this, we have with us great academician, Professor Singh sir. It's a great privilege and honor for me to invite our respected senior most member of our specialty, Master of Masters, Teacher of Teachers, Professor Singh sir. He does not need any introduction. He has a lot of contribution to our specialty. He has worked in various capacities. India's apex PMR department, that is PMR department of AIMS New Delhi in various capacities, and he has headed the department for long 22 years. Even after his superannuation also, he has not quit from his academic field. He has joined again as professor at Mahatma Gandhi Medical College Hospital, Jaipur. He has worked in many research projects as principal as well as co-investigator. His contribution on multi-axial orthotic hip joint and development of I-shape model for various disability conditions are the greatest contributions to our specialty in the form of different research projects. He has around 29 publications and 16 chapters written in various books, and he was our editor of our IAPMR journal for long 17 years. Lots of award to his credit, starting from Alimca Award, W.G. Rama Rao Travel Fellowship Award, IAPMR Gold Medal Award, so many things. His biodata itself is a book, sir. So you really do not need any introduction beyond this. So every member of specialty know about Professor Singh, sir. So I don't want to waste my time, your valuable time in this webinar. Let us invite Professor Singh, sir, to start his presentation on human gait analysis normal. Welcome you, sir.
Thank you so much indeed for such a wonderful wonderful introduction. Actually, I am really sorry to give such a short notice and trouble you at such a short period of time. I was getting requests from my students from different institutions to talk about gait. Previously, during the conferences, we had been doing quite a bit. And I would like to say that Dr. S.K. Verma, who lived until the last year, his anniversary was day before yesterday. And we wanted to actually commemorate this talk to our great soul, Dr. S.K. Verma, who had been my teacher. So we will start with the presentation now. I hope you are able to see the slides.
Yes, sir. It's
okay.
Visual.
The important thing is that I would, the topic is very long, so we divide it into maybe 1 or 2 more lectures. So yes, when there is time, you can stop so that we can have questions so that we can continue in the next talk. So as we know, human gait is a very complex thing, and we have to understand because we have to work on. Somebody has to mute his mic. We can hear somebody talk inside, please. To understand what is gait, we have to understand what are the various things which get along with the gait or which are read with gait. So in case we talk of the animal move from one place to another. That is called locomotion. That is not gait. Second is humans walk on 2 feet. So the method of locomotion involving the use of two legs alternatively to provide support and propulsion. But important thing here is that one foot must remain in contact with the ground at all times. Like when we run, we have a time when we don't have any foot on the ground. We are in the air. Both the feet are in the air. So that is a difference between walking and running. Gait is a manner or a style of walking. How we walk, that is our signature. It is said that the people walk typically. You could ascertain how Devanand walks even from a distance. So it is not the walking process that we talk about. We talk about the differences in the gait and not about walking. So that is what we are looking at, the difference. When we talk of gait, we talk of the gait cycle. What is gait cycle? Like in case you see in the figure below and you look at the shaded leg, which is the right leg of the lady below, we say the time interval between the two successive occurrences of one of the repetitive events of walking. It's very complex to understand or to repeat the definition, but it's very easy to understand in case we say that the lady has placed the foot on the ground and then she takes a complete step and the other step, and subsequently when the foot comes on the ground of the same leg, that is typically known as the gait cycle. You can start from anything, but that is the most precise moment that the foot comes in contact with the ground at that particular time. There used to be a traditional terminology, as you see on the left, heel strike to foot flat to mid stand to heel strike, and then again toe off. That is what we call during the stance phase. And the Ranchos Los Amigos, they said that number of people don't have heel strike. They may have a foot flat or they may be landing on the forefoot. So they say initial contact instead of heel strike. So when the foot has initial contact on the ground, that is known as the initial phase. Then you have a loading response as the foot takes the load, and the mid stance when the foot is on the ground and the other foot is in the air. So we'll talk about these things. The terminal stance means the foot is about to get off, and the pre-swing when the foot is about to go up in the air but still is in touch with the ground. We talk about one particular leg, not both the legs together, because it is the alternative thing which will keep on happening. So in case of the swing phase, we talk of the toe off to the acceleration to the mid swing, and then we decelerate after the mid swing to go into the terminal swing. So we have the initial swing, mid swing, and the terminal swing. The things might appear a little confusing to you. And I tell you that our teachers used to challenge us that you can't understand gait and you can't really replicate the way it is. But if we say, how do we understand it? See a person walk. So as soon as a person has the one foot on the ground and the second foot on the ground. So again, you see, as soon as the first contact is there, the same foot, the second contact is there, that is called a stride. So now we talk of, just a minute, the steps. Left step, the right step. As soon as you have the contact on the ground, once again we play it. As soon as you have right foot contact, left foot contact, the distance between the two is the step for that particular foot. Now, understanding how the placement of the foot is there, we will try to understand what is step and what is a stride. Stride, of course, in case you go by from one foot, say the right foot, which is in red, going up to the next step of the right foot, that is the stride length. Or in case you talk of the left in the green, from the heel strike or the initial contact to the next initial contact of the left foot is the stride. And that is the gait cycle for the left foot. And in case we talk of the right is the stride length and the gait cycle of the right foot. And in case you see the right foot and the left foot, the distance between the two is the step length of the right foot, and the distance between the subsequent right foot after the left foot is the step length of the right foot. So this is how we talk of the stride and the step. And we also have some angle with which the foot is falling on the ground. That's called the toe out angle. And in case you check the distance from the midpoint of the heel or both the feet together, and then you check the distance, that is the width or the base of the gait. So we have right or the left width going along with the line. In case you look at the persons with cerebral palsy, they might have a negative walking base. So this walking base is the distance between the progression of one foot and the progression of the other foot, and the distance between the lines of the two. Now we talk about, in the gait cycle, we have two major phases, which is called the stance phase when the foot is on the ground, and the swing phase when the foot is up in the air. So you look at the foot in the yellow. As soon as you have the initial contact, which is called as a 0% of the gait cycle, then it comes into the loading response. That means initially we might have the heel in the normal gait, and then you have the foot coming gradually down, and then you have a mid stance when the other foot is in the air, and you have more or less the center, the body weight is more or less on the center, and the body is being thrown forward. And then you have the terminal stance when the foot is still on the ground and it is about to go up in the air like this, until here we call the swing phase, that it is still in touch with the ground, and then it goes off the ground. It goes into initial swing, mid swing, and the terminal swing. And we also have to look at the other side. There are so many things to be looked at: how the upper body, how the arms, how the trunk, how the pelvis is going. But important thing is that most common things that we check for the legs is the stance phase, which covers approximately 60% of the total gait cycle, and the swing phase approximately 40% of the gait cycle when the foot is up in the air. If you walk slow, the stance phase will become bigger, and in case you walk fast, the swing phase will become longer. When both the feet are on the ground, like we have the initial contact and the toe is still up there, that is called the double sport. And as soon as the foot goes into, the other foot goes up in the air, you have a single sport. And again, the double sport comes once again. So you have 2 feet on the ground simultaneously, 1 foot goes up, and that is called a single sport. And the double sport is in case you see approximately 20% of the total gait cycle is the double support. Looking at it once again, we have the heel strike, toe off, mid stance, heel strike. So we have double support here, and again a double support here, and the single support of the left foot here. That means the stance phase of the left foot, and the stance phase of the right foot, which is in yellow over here. So you have the swing phase of the right foot here and the stance phase of the right foot here. So this is the chart basically for you to understand the gait cycle which we talk about. We talk about the percentage starting from the initial contact to the time of the next initial contact, which is 100% of the gait cycle. So whatever occurs in between this 100% is taken as the measure. And you divide that into stance phase and the swing phase. Now, in case you look at the gait cycle, we have a stride. Stride is comprised of stance phase and the swing phase. You talk about one leg, not both the legs together. So in this stance phase, you have the weight acceptance, which means initial contact, and the loading response. And then you have a single limb support, mid stance, terminal stance, pre-swing. And in the swing phase, you have the limb advancement. That means the body is thrown forward and the other foot goes up in the air and then takes the load. So it starts soon after the terminal stance in the pre-swing phase, and we have the initial swing, mid-swing, and the terminal swing. So these are the various stages of the gait cycle, majorly being the stance and the swing phase. Now, looking very closely, in case you look at the leg with the right dot, that is the one we are talking of. So we have the heel strike normally when both the feet, this is heel is off, toe is about to go off, and the heel has just touched the ground. You can see in the reflection also that it has touched the ground. That is the initial contact. As soon as the heel takes the load, the foot starts to come down, and you have the foot flat or the loading response coming up, and the other foot is about to go into the swing phase. So in case you see that this is the mid stance, must mind that the body is tilted forwards. In case you look at the stick figures, after the loading response, the foot goes from the blue line, in case you see the stick figure, goes from back and comes to the front, and we are talking of something happening in the middle, and the other leg is up in the air. And the terminal swing is that after the mid stance, the other leg is about to land on the ground. It has not touched the ground, and you have the heel off. And as the heel keeps on going higher and higher, you will have the toe off of that side. And this will have a loading response onto the opposite side. So this is the actual mechanism or the phase that you see in the persons having gait. And after the toe off or the pre-swing phase, you have the initial swing, the other leg goes into stance phase, and then you have the mid swing, and then you have the terminal swing. And after that, of course, you will have the heel contact or the initial contact of the same foot. So that is the complete gait cycle up to the terminal swing. When we have to do the measurements of the gait, we know what is happening at what particular phase, and we have to understand that. And there are certain parameters that we call the general gait parameters. The general gait parameters, you have, of course, the important thing, we know the stride, what is stride and what is the stride length. And we measure that in meters as per the convention. Then we talk of the cadence, number of steps taken per minute. It can be fast, it can be slow. So we call that in the numbers per minute. And then we have with what speed or the velocity the person walks, or the meters covered in a minute. That is the speed. So these are the three basic or the general gait parameters that we have to measure, which can be done by anybody using a tape or something like that, and or a stopwatch along with it. For the stride length, what we do is the distance between two successive placements of the same foot. Like we have the initial contact of one foot to the initial contact of the same foot in the subsequent step. So normally we say, depending upon the height and the mood and the speed and how is the flexibility of the joints and the mobility of the joints, normal person would walk between 1 to 1.5 meters in a stride. So that is how much a person can walk. Second thing is, I think there is some. Okay, the steps per minute, of course, you can count using the stopwatch. That is, stride is apparently missing. Then we talk about kinematics. Kinematics is the reference to the motion without reference to the forces involved. In this, we measure the joint angles in the different phases of the gait cycle. Here, it might appear very complex to you because the body keeps on moving and you have to check what joint is at what level in what phase of the gait. So that is what we need to know. In case you have seen number of patients with your naked eye and know that in what phase, how much is the angle at the hip, knee, or ankle, you can differentiate in an abnormal condition how things are different. And this is very, very important from our point of view. Here we talk of the joint angles. So these stick figures are very, very commonly used to depict, but these don't give us so much of an information, but at least you know how the joint, this is like flexion at the hip, flexion at the knee, and ankle more or less neutral. So here we have a plantar flexion at the ankle, a lot of flexion at the knee, and almost neutral at the hip. So this is extension at the hip, almost extension at the knee, a little bit of flexion, and we can't see what is going down. So we have to discern what is happening in the joint angle. So we're talking of the kinematics or the measurements of the joints. In case we draw a diagram, how the curve goes, these are the angles in the hip. In the hip, we have the flexion on the top and extension at the bottom, and we talk of the degrees. So the hip has, at the time of heel contact, approximately 25 to 30 degree angle, and it keeps gradually going down, and just before mid stance it starts to go into extension, and it is into the maximum extension just at the time of between the heel off and the toe off, and then as soon as the swing phase comes in, it starts to come into flexion once again, and the cycle keeps going. How much is the deviation and how this curve is, whether it is smooth or it is jerky, or it has adequate extension and flexion angle. So this is what we will like to have a look at. So this is how the cycle would go. In case we know at the knee would be more or less neutral at the time of heel contact, but soon after that will go into its little bit of flexion, and by the time of mid stance it will still be in flexion, and then at the time of swing it will start to go into further flexion. It will not have any extension, which is normal. It is almost neutral just at the time of heel contact and just before mid stance, and then again we'll have flexion, and then it goes into this kind of a cycle into the gait. So this is the way you will see. We will come to what is important in a little while later. For the ankle, there is very little movement. Initially at the time of heel contact, it is more or less neutral. And as we go into the loading response of the foot fat, it goes into a lot of flexion. And then it is, as the mid stance comes, it will come to more or less neutral or a little bit of dorsiflexion. And then suddenly after the heel off, it will go again into plantar flexion. And then to clear the ground, it will come to neutral and a little bit of dorsiflexion once again. So this cycle again keeps going. So this chart is the most important chart for the joint angles, which we have to understand. So in case you look at yourself, the way you walk, look at yourself in the mirror, or do a recording of yourself on your cell phone or on the computer or the camera, and then you analyze, you will be able to check these joint angles very well. And I also used to joke, in case you have a question in the examination, what is normal gait, and you don't remember what happens, you just ask for a small excuse from the examiner, go for a toilet, and on your way back to the toilet, you can check how the joint angles are at what phase, or you can simply go have a glass of water in case it is lying on a table or outside the class, and then you can easily understand what are the joint angles at a particular time without having to mug this up. Along with the legs in the hip, knee, and ankle, whatever we see, we also have the upper body movements. What happens to the upper body? If we look at how the gait is, we disbalance ourselves by falling forward, and then with the legs, we try to catch or prevent ourselves from the fall, and then we stop and then again move forward. So we have to move forward. That is what happens with the upper body. And there is a change in velocity. During the swing phase, we rapidly move forward. To the stance phase, we have a little slower velocity. The trunk also twists. In case you look at the pelvis, pelvis goes forwards, backwards, upward, downwards. So the trunk, in case we go along with the pelvis, the trunk will twist as we take a step. The trunk has to go in the opposite direction. Like the right foot is going down, we move over arm. At the same time, the trunk moves in the opposite direction. The arm movement is there. Shoulder movement goes opposite the hip to balance, so that we keep on, we don't walk like this. We walk more or less straight. And the pelvic girdle also moves. So these are the things we also have to check. Depending upon where the pathology is, what we are trying to check, we go by that. So the trunk with the flexion, it will go into flexion during the heel, like the left foot is forward, and the right arm and the trunk will flex. At the same time, it will rotate transversely. And there is extension during the single limb sport. We have different planes. So in case you simply understand, the left foot comes forward, the right trunk will twist and will also bend. And it is maximum at the heel strike. As the weight comes on, say, 1 foot, the body will have to balance and will have a sway onto the lateral side also. This is an important thing to understand, so that we keep walking straight. The head doesn't twist right or the left along with the foot in case the body is stiff. In case you see somebody who has ankylosing spondylosis and the way he walks, you will see how the movements are, how the upper body and the trunk moves. So upper limb movement, as we know, we have the swing of the upper extremity opposite to the lower extremity. In case the right foot is forward, the right arm comes forward. If the left foot goes behind, right foot goes behind, the left upper extremity will go behind. And that also gives some bit of energy to the trunk to rotate. And it also reduces down the rotation on the lateral sway of the body because of the upper limb movement. You try walking with your pelvis and the shoulders absolutely in one plane, and without moving the arms, you will walk something like this. But when you walk, you don't really see that. If you see the horse, you will see that the body where the rider is sitting and the head, they are more or less in one plane, and rest of the body, feet, the hind pelvis and the shoulders, the forelegs, they are moving, but the body sitting on the top will not go up and down. Similarly, our body also behaves in a similar manner. The center of gravity, as you know, is placed somewhere close to the lower end of the L1 and upper edge of the L2 vertebra. When we move, it goes up and down. As you know, during the stance phase, it goes highest. And during the swing phase, it will go on the lower side. And as we place the right foot on the ground, the center of gravity will move up and it will go up. During the double stance phase, it will go down. As you see here, the vertical displacement of the center of gravity, single stance is the highest, double stance, it is the lowest. That means at the heel strike and the toe off stage. So it keeps going up and down. At the same time, it goes sideways. In case you see the center of gravity movement, it will keep on going in circles like this, going forward, because it has to sway down and it has to come up. In case we had a ball rolling, it will go absolutely in one single axis. But here we are not a ball. We have the different angles and we go up and down. The pelvis goes up and down. And as we extend the leg or flex the leg, the center of gravity keeps going up and down. So this in movement is extremely important, and it is very difficult to check the center of gravity movement. We have to find a correlation. We have to make coordinates between the anterior spherical spines, the posterior spherical spines, the hips, and then we check how much is the rotation, how much is the sway, and then based on that we check the center of gravity. It is not there in the books very much. When I was in England, I was working on the gait analysis. We tried to do a coordinated approach to find the center of gravity in the persons. I was doing study on the amputees at that time. After we have measured the joint angles, we talk of the various forces. Forces in the sense, forces, moments, mass or acceleration, position and orientation. We call that as a study of kinetics. So kinetics is also an important thing. What is involved? How much force? What is the kind of movement? What is the mass? With what speed it is going, or the acceleration or deceleration? And in what spatial configuration, 3D, whether it is which orientation it is there. So in case we look at how the green figure is the person when he is putting the foot down, and these are the forces coming. How do we resolve which direction it comes? So we have to check. Most commonly found are the ground reaction forces. We use the force plates or other measures to check how much is the ground reaction force. The ground reaction force, in case we check vertically, the lowest most figure, and we check the horizontal line is the body weight. Based on the body weight, when we have the heel strike, it will go beyond the body weight. And during the swing phase, again, it will come down and then rise up again for the next at the time of push-off. So in the whole gait cycle, that one foot is going like this and the other foot is going like this. At the time of heel strike and the push-off, when we throw the body up, there is a lot of force vertically which is required to counter the body or to throw the body up in the air. Or when we land, we also put our weight down, and that is how we measure it, and it goes beyond the body weight. In case we say fore-aft, forward and backward, this is how it is. Like at the time of heel strike, it is a little forward, then it goes backward as soon as we try to push our foot down. And as we go into the swing phase and try to land on the ground once again, it will again have a forward kind of a force. Laterally, as we put our foot down, let's say the right foot we have put down, it will initially have a little tilt onto the lateral side. Again, the force will come onto the opposite side as we try to take the push off. So you can imagine when we are walking, we are having forces coming like that. So we have to have three coordinates for the forces: the fore-aft, lateral, and the vertical. If we look at the foot pressures, we have the foot mats and things like. So this is how, with the heel strike to the toe off, the foot pressures peak. And here are the peak pressures as we see, and this is how the weight line goes. And heel strike as the foot comes onto the ground, and then we have the flat foot, and then we have the heel off, and then we have again going further into the terminal stance, the weight comes up. And as soon as the pre-swing phase comes, there is very little weight here on the forefoot, and then there is nothing. So we can check the foot pressure only during the stance phase, of course, and that is how the distribution goes. So we can check what are the peak forces and where they are. It will have an implication in case somebody has an abnormality or a contracture and the foot is coming very high at one particular point, or somebody who has ulcerations in the foot. We check the dynamics, how much weight is coming, whether it is going beyond the acceptable limits, and then we can reduce down with the orthosis. So foot pressures is a very important thing to understand. Vectors are the force coming in a particular direction. At what angle, as soon as we put the foot down, at what angle and how much force is coming. Like as soon as you have the foot flat, and then not a foot flat, heel strike, the forces are a little low. And as soon as you tend to have towards the full weight onto the heel and the other toe off is coming, we have the peak force in this direction. And as we come into the foot flat, the forces come down because the other leg is thrown up in the air. And again, when we go into the heel off and the toe off, again we have a peak. And you see the direction of the forces onto the ground. You can imagine as we come forward, the forces would be downwards. We will push downwards and the ground will react with a vertical force backward and upwards. So these are the vectors which will let us know. In case you have not a smooth array of vectors, that means there is something wrong. So the smoothness and the height and the direction of the forces, we understand it. This is typically called a butterfly diagram, and it may be abnormal. Now we talk of the moments and the torques. So many moments, they are so complex, but we talk of what are the basic moments we resolve in all the three axes. So the most common moments at the point of heel strike, what is the total force with the direction making that particular movement? At the time of heel strike, of course, it's a moment of flexion. Like in case you put the heel down, the hip is already flexed. It will keep on having further flexion in case you keep on putting that force. As soon as you come into the mid stance, we have foot flat, we tend to come into extension. At the time of mid stance, we are almost in extension, and then it will keep on going. Soon after the heel off and the toe off, it will tend to go into flexion once again. I'm sorry, the other way around. As we put our foot down, the hip will be pushed into extension. If it goes into flexion, we tend to fall. And as we go towards the swing phase, it will come to the flexion movement. And at the end of the swing phase, it will go into extension movement so that we don't fall. The knee, the downward is the flexion. As soon as we put our foot down, in case we didn't have quadriceps, we'll buckle. That is why we have the flexion movement. And soon after the heel strike, we tend to have an extension movement to keep the body erect. And then around the time of mid stance, it will come to a little bit of flexion to maintain the height. And then at the time of toe off, it will go into a movement which will cause the movement of extension at the time of deceleration, from mid swing to the deceleration. The ankle, as we put our foot down, as soon as we land, the moments are for the plantar flexion. And it will be peak at the time of, the plantar flexion movement would be peak towards the terminal stance so that we throw our body up into the air. These are very difficult to understand in the beginning, but once you do gait analysis with an equipment, which is not very rare to find these days, you will be able to understand these. Now we also have to look at what is the amount of energy that we use. Because we don't have something like a ball which is rolling on the ground that once the momentum is gained, it will take only the friction to stop. We start, we stop, we start, and we stop. It goes like this. So we take a step, take another step. We have starts and stops. Second, the body also rises and falls. So that consumes energy. And transfer of energy, potential energy into kinetic energy and kinetic energy into potential energy is a very, very important thing which will have the efficiency of the gait. Before we talk of that, we will talk about what muscles act at what particular phase of the gait. And their understanding will also tell us, in case a muscle is weak, what kind of a phase the gait will be affected. If we look at the hip gluteus maximus, we say the main extensor. At the time of heel contact, it will contract so that when the foot falls on the ground, it doesn't land into flexion of the hip. It will keep the limb erect. And as soon as you tend to go towards the mid-stance phase, just before mid-stance, the limb is already vertical, more or less vertical. The gluteus maximus doesn't need to act. But at the same time, again, just before heel strike, it will start to act again. There is nothing like that to keep it extended. We need to have any movement of the gluteus maximus. So it can relax in between the gait cycle. It works only for a short period to prevent the buckling or the flexion of the hip and to keep the leg straight. Iliopsoas comes into act soon after the mid stance because it has to initiate the hip flexion. Once the hip flexion is there, at the time of toe off, it will have another peak to throw the leg into the mixed swing for the acceleration phase. So only for the acceleration and to initiate the swing, iliopsoas acts. Hamstrings, they have a braking effect. Like when the foot is touching the ground, heel contact, it has to prevent the knee from getting buckling or having flexion. So it has to, when the, let's look from here. When there is a mid swing phase and there is a deceleration phase, the knee flexion is very fast during the initial swing and the mid swing, and the hamstrings create a braking effect on the knee flexion or the knee extension at the time of the late swing. It is a brake which is put in. In case you look at the prosthetic knee joints, to compensate for the hamstrings, we add friction. And adding friction, either we have a constant friction knee joint or we have the various kinds of hydraulic, pneumatic, or the electronically controlled computerized knee joints. So that is the function of the hamstrings. Quadriceps, the main function is to prevent the flexion of the knee at the time of initial contact and the time it goes into foot flat and goes into mid swing. After that, there is natural locking of the knee joint. We don't need the action of the quadriceps to maintain it unless the person has a flexion deformity where the action of the quadriceps will be maintained. And again, at the time of toe off, we have to keep the knee fully extended and through the leg just before the swing phase, that the action of the quadriceps will be required to prevent buckling once again. Triceps suri. At the time of the foot flat, because this comes passively, at the time of foot flat to the mid stance, it will start to have some bit of building of the energy. And just before toe off, it will have the peak after the heel off and the toe off. So after that, it doesn't need to. Then the question of the tibialis anterior comes just absolutely opposite of triceps suri. Tibialis anterior comes into force at the time of a heel contact. As soon as a heel contact is there, and if you don't have the tibialis anterior, the foot will absolutely slap on the ground. So we'll have a slapping gait. So that after the heel strike, the foot gradually comes down, the tibialis anterior comes into play. And at the time of this, during the swing phase, the foot is hanging down. It is in little flexion, and then it comes into neutral or a little bit of dorsiflexion just before the next heel strike so that it doesn't drag on the ground. So you have a high steppage gait in case tibialis anterior is not there, and you also have weak tibialis anterior, you have a foot slap. So that is what you need to understand the EMG for. Dr. Sahoo, up to here, it is very simple. Now it becomes a little complex since we have 15 minutes more. Tell me how much more should I carry on?
Sir, we have to finish by 7 p.m. because the Karnataka chapter they have booked the time
Okay.
from 7 p.m. almost.
Should we take questions or should I carry on for another 5 minutes lecture?
Sir, you can carry on for another 5 minutes. After that, we'll have questions.
Okay. Okay. Determinants of gait is a very important thing that we have to understand, because it is not only for the sake of the human gait efficiency, but also is very commonly asked in the examination. What do the determinants do? They optimize the excursion of the center of gravity to the minimum so that it doesn't go so high, so low. In case we say measure it, it goes up to 50 millimeter up and down, 50 millimeters on the side, or 2 inches maximum. In case you don't have the determinants, it may go 3 or 4 inches also. The purpose is to reduce down the consumption of energy when the person is walking. So what are the various determinants of gait? It is done by pelvic rotation, the pelvic tilt. So we have 2 things in the pelvis. Then we have knee flexion in stance and ankle and the foot mechanism. Plus we have the lateral displacement. So we look at around the hip, pelvis, around the knee, foot, ankle, and the whole body displacement from side to side. These are the 6 determinants of the gait. So the first determinant is pelvic rotation, which reduces the angle of the hip flexion and extension, which in turn reduces the vertical movement of the hip. In case we see hip, so it goes up. The body height goes up, the center of gravity goes up as we go from the initial contact to the next contact. But how much is this is compensated? In case the pelvis was not coming into play, the hip would have hiked very much. So it moves, tilts to side plus forward and backward. So we have the pelvis rotation as well as the pelvis movement, fore-aft movement. Second determinant of gait is the vertical movement of the center of gravity is less than that of the hip due to pelvic tilt. So we have the pelvic rotation in the previous one and the pelvic tilt in this, so that when the person is walking, like we have the double stance, it is here. At the time of mid stance, one foot goes higher, the other foot goes down. So that the center of gravity, in case we look here, doesn't rise so much. And at the same time, again for the next, it doesn't dip so very much. We will talk about how much is it dipping when we also understand the foot ankle mechanism and the knee mechanism. In case we look at the knee joint, at the time of heel contact, the knee is to the maximum extension. As soon as you have the stance phase, in case this much extension was going, in case we resolve the angles, this angle is contributing to the height. In case the foot is flat, the hip would have gone higher in case the knee was not flexed. That means to say, in case the knee was not fully extended and the heel was not in touch, the center of gravity would have fallen. And at the time of stance, in case the knee was not flexed, the center of gravity would have been higher. And at the time of heel off, in case the knee was not extended, it was flexed, it would have moved further lower. And at the time of toe off, in case we didn't have the knee flexion, the pelvic, the hip or the center of gravity would have gone higher. So it is trying to prevent this upward movement of the center of gravity and reduce down the dipping of the center of gravity by optimizing the angle of the knee according to the phase of the gait cycle. So the knee is the third to the fifth, along with the heel. So when we extend the leg, the heel extension would also add on to the height. And at the time of toe off, again, it will add up to the height. And the last determinant is we keep the feet close together so that the side-to-side movement of the body or the center of gravity is not there. So like in case you look at here, in case the feet are wide apart, the center of gravity moves side to side a lot, but in case the feet are close together, the center of gravity doesn't move that very much. So pelvis, knee, hip, ankle, everything works in unison. Look at the air hostesses training when they put a glass on top of their head and they make them walk so that their head doesn't fall up or sideways. So that is the most efficient gait. Of course, it will consume a lot of energy down there in the legs and the hips. So that is how it will be. So you have to look at pelvis. What is the mechanism? What is the mechanism at the knee? What is the mechanism at the ankle and the foot? So they will optimize the energy consumption. In the extremes of age, the children generally don't have a heel contact. Their stance or the knee flexion is very low. They walk with flexion in the knee. And the swing, the hips go into external rotation and the arm swing is absent. And their walking base is wide, stride length is low. They take very high steps, or the stride length being low, they'll walk with a very high cadence. And their velocity naturally is low because they have very short legs. So in case you look at here, this is how the angles would be. And they don't have complete extension of the knee during the stance phase. In old age, we generally have a flexed attitude and low cadence, low velocity, and low stride length. In the young people, they are erect and they have wider, longer stride and higher cadence. So I think I'll stop here and we will take up questions because others will take a very long time.
Okay, sir. Thank you very much, sir, for a wonderful presentation. Let me see if there is any question in the chat box. So far, no question, but there is a request to continue of the lecture in the subsequent phase. So
Yes.
the phase depends upon your availability, sir. Whenever you are available, we can go to the second lecture on the same topic to complete the topic.
Sure. Because the trouble is, it is so much of condensed information. It is very difficult to gather everything and remember everything. One has to really understand it. So the best way is watch yourself and check what things are, and how we do it, we will talk about in the subsequent lectures. There are a couple of questions. Can we?
Yes, sir. Some questions are coming up now. Yes, we can discuss some questions.
EMG of muscles, is it just concentric contraction graph that shows, or eccentric? It is both concentric and eccentric. Like the tibialis anterior would have an eccentric contraction at the time of coming to foot flat, and a concentric contraction during the swing phase. And EMG muscle concentric, eccentric. When we start to walk, the hip first extend. Okay, the question is from when we start to walk, the hip first extends. I don't think so. In case you are standing erect, the foot which is being placed forward, the hip will flex, and the foot which is behind, the hip will extend. So that is how it is. So do we have any more questions?
No questions, sir.
Okay, thank you very much for listening to me, and I believe that the students would have got something. It is not a very difficult topic in case you apply it onto yourself and try to understand, but it's important to know what we need to see in a gait. So that will cover in the subsequent classes. Thank you so much, Dr. Sahoo.
Thank you so much, sir. Thank you so much, sir.
Thank you very much, sir. I must thank from the core of my heart, sir. Whenever I have asked for any lectures on this webinar for the students, every time you are always agreed to take a webinar, and really we are very much thankful to you, sir. And really wonderful lecture. And I must suggest all the participants, the juniors, whoever have not attended the webinar also, it will be available on the YouTube. See, this is a topic which you have to go through repeatedly. You have to go through the lecture repeatedly, imagine the whole things, because you have to assimilate the things so that you can understand, you can remember. So to assimilate the whole thing, you have to see it repeated. The lecture you can see it repeatedly. Assemble yourself. Go imagine the things how you are moving. Then only you can remember these things. One more thing I would like to mention it here also. We have friends from Bangladesh also. They are joining with us.
Really?
And hopefully they must be enjoying this lecture, and we'll expect some lectures from their side also.
Wonderful.
So thank you very much, sir. And I must also thank to the organizers of our PMR department and office bearers of IAPMR for giving us the opportunity to providing Zoom platform and uploading the webinar whole talk in the YouTube so that students can benefit out of this. So I must thank all the office bearers of IAPMR and Odisha Association of PMR also. And thank you very much all participants who have attended this webinar. And thank you very much, sir, for accepting our invitation. Thank you. So
Thank you.
with this, I conclude this webinar. Thank you, sir.
Thank you very much.